Hi, Matthew. This is Unit 7, Lesson 4 Practice, and this is found on page 180 of your workbook. So in the first question, it's talking about a quadrilateral A, B, C, D. Keep in mind that no matter what it looks like, so disregard that this looks anything like a rhombus or a parallelogram or anything like that. But just remember that when you name it, you could start at any vertice and you just move your way around. So no matter where you start, A and C will be opposite each other, and B and D would also be opposite each other. So in this problem, if these were the given measures, they want us to select all that would come from a cyclic quadrilateral. Remember, to be cyclic means that it can be inscribed in a circle with its vertices on the circle. So this would mean that our opposite angles have to be supplementary. In other words, our opposite angles have to add to 180. So I'm looking, specifically when I look, I'm looking for angle A and C to add to 180. Doesn't matter what they are, I'm looking at the sum, and if they add to 180, great. And then I'm looking at B and D. So the next thing I look at is B and D because they're going to be opposite. Wherever they are, they're going to be opposite. And I'm looking for them to equal 180. So in this case, 90 and 90. So my B plus D would be 90 plus 90, which is 180. Check. And my A plus C would also be equal to 180, 90 plus 90, check. So then this first one, that quadrilateral could be cyclic. It could be inside of a circle because its opposite angles were supplementary. Taking a look at an example like example C, for instance, if you look at this particular example, A plus C would only be 140 degrees. So those two opposite angles would not be supplementary. And angle B and angle D add up to 220 degrees. So B plus D would be 220. That is also not supplementary. So that would be an example of a quadrilateral that would not be cyclic and also would not be able to be inscribed inside of a circle. So let's take a look now at question 2. Question 2 is exactly what we were learning in our class today. In order for A, B, C, D to be cyclical, notice that it starts at A and they just go the other direction. But A and C are still opposite of each other and B and D are still opposite of each other. So in this problem, they say what's the measure of C and what's the measure of D. So for example, to find the measure of angle C, it's opposite of A. So I would want angle C plus angle A to equal 180 degrees. So for example, if I took 180 minus 135, I could get the value for angle C, which is 45 degrees. So let's take a look then at number 3. In number 3, it says Lynn is looking at a cyclic quadrilateral ABCD, and she's not convinced that they always add up to 100, the opposite angles always add up to 180 degrees. So it's talking about moving angle A. So in this case, no matter where you move A, so I could move A somewhere else, but across from A would still be the same arc. This same arc would still be on the other side of A, and this arc must be 160 degrees in order for A to be 80 degrees. So it doesn't really matter where you put A on this side of the circle, since the sides of the angle are going to still go to D and B. It's always going to be an inscribed angle for this 160 degree arc. So it's always going to be 80 degrees no matter where you place it on that side of the circle. Taking a look at question 6, taking a look at question 4. Taking a look at question 4. says line AC is tangent to our circle. So that means that angle C would be 90 degrees. OC is a radius and AC is a tangent line. So it says that the radius is 3, so I know my radius. And then it says the length of segment AC is 4.5, which they've already wrote on my diagram. And then it says find the length of segment AB. So I can find the length of segment AB, but what I'm going to find first is the length of my entire hypotenuse AO. I could use the Pythagorean theorem to find that. This is a right triangle, so I know that AC squared plus OC squared is equal to my hypotenuse OA squared. So for example, I know that 4.5 squared plus OC, which is 3 squared, is equal to my entire OA squared. So now follow this idea. In this case then, 4.5 squared plus 3 squared would give me 29.25. So the square root of that is equal to OA. So the square root of 29.25 is equal to OA. So that's the entire blue segment, but I really only want AB. So remember, my radius is 3. So OB is also 3. So if I take the entire blue segment, which is my square root of 29.25, and I'm on purposely not calculating that because I can see it's in my answers right here, and I subtract 3 from it, that would be the section that's OB, I would have the leftover AB that I'm looking for. So looking through my answer choices, C is the one where I'm taking the entire length of OA and I'm subtracting, sorry, my blue circle just went through the negative sign, but this was a -3. And so I'm subtracting 3 from it. That leftover piece is going to be equal to the little tiny segment AB. So number 5. Taking a look at 5, we did a similar problem to this in the last lesson. In this one, we know that PD is tangent, so we know that this is a right angle. And we'd like to find out how far B is from P. So I'd like to find the small distance here. And I'd also like to find out, is B or C closer to P? So in answering that question, I really have to find both BP and I also have to find the distance from CP. It's really 2 separate problems. So I need to find those 2 distances to answer my question B. So in order to find BP, I use the right triangle that is the entire, so I'm going to do it in blue. I use this entire right triangle. And in my problem, I'm told that my radius is 1 inch. So that would make OD 1. It would also make AO 1, or AD, the entire side, would be 2. So in order to use the Pythagorean theorem with the larger blue triangle I just drew, I would have PD, which is 1.2 squared, plus AD, which is the entire diameter, so that's a length of 2 squared, equal to the hypotenuse of that blue triangle, and the hypotenuse is AP squared. So that's using the Pythagorean theorem on the blue triangle in my picture. And so that would give me 5.44 equal to AP squared. When I take the square root of both sides, I get 2.33. is what AP is equal to. Remember, I wasn't trying to find AP though. I was actually trying to find BP. So taking the entire side AP and subtracting out just this 1.7, which is the distance between A and B. So subtracting out 1.7, which is the distance from A to B, the leftover distance is BP. And that leftover distance is equal to 0.63. So I did that work to find BP, which is 0.63. So next I'm going to find CP. So let me change my color that I'm writing with. And so I'm going to find CP this time. I'm actually going to use a different triangle. I'm going to use the right triangle that has segment CP in it. So if you could look at my diagram, I'm going to use this right triangle, the red one. The red right triangle contains CP. So using my Pythagorean theorem, I again have PD, which is 1.2 squared, plus then OD, which is just a radius, so it's 1 squared. And that would be equal to the entire OP segment. That's my hypotenuse. That's the side across from the right angle, so it's the hypotenuse of my triangle. So when I calculate these with my calculator, I get 2.44 equals OP squared. So when I take the square root of both sides, I get approximately 1.56 is equal to OP. And please remember that's not what I was trying to find. I was trying to find CP, which is just this little portion of OP. And then this from O to C is a radius. So from O to C is just 1 unit. I just wrote that on my diagram. It's equal to 1. So if I take the entire OP, 1.56, and I subtract the radius of 1, my leftover length is CP. So when I do that math, I get 0.56 is equal to CP. And so I know that CP is 0.56 units. So obviously, we answered question A before, and now question B says which point are closer to P. So obviously C is closer to P. So C is closer to P because it is only 0.56 units away. And then taking a look at on my third page, number 6. Number 6 is an inscribed angle, central angle problem. So you can take a look at the answers. They're in the locker. And on number 7, it says the circles and a line are drawn. How many intersection points are possible? So if you're having trouble with that one, I will tell you that you could have no intersection points, so none. Or you could have just one intersection point because you have a tangent line. Or you could have 2 intersection points because the line is a secant line and goes through the circle. Again, if you need to look at that diagram, the answers are in the PDF in the locker. Thank you very much.